this question is about the Young modulus and the relationship between cross-sectional area, length, and the extension. So we're asked for which combination of properties will produce the smallest extension of a wire. So the standard equation is that the Young modulus is stress over strain. The stress is the force over the area, and the strain is the extension over the original length. So you can write it like this, and that ends up that the Young modulus is FL over delta L A. Now in this question, the cross-section area is given as capital X, Young modulus is E, and the length is L. And what we're interested in is the relationship between the extension and these properties. So the extension is delta L, and then we end up with FL E A. Well, for this question, that A is capital X. So we've got this relationship. So if I want to minimize the extension, and this should make sense in terms of you just thinking about what's going on. If you to minimize the extension, I need to minimize the force or minimize the length, or I need to increase. So these are directly proportional. If I can, increasing these will reduce the extension. So increasing the Young modulus, that will make, that's as if the material is stiffer. So if stiffer material gets less extension, that makes sense. So increase the Young modulus or increase the cross-sectional area. And increased cross-sectional area requires a bigger force with the same stress. So we just need to look at the lines now, which give us the maximum effect. So what we have is cross-sectional area of X for the first line, 3L, and then we've got Young modulus E. Okay, so that will give us we've multiplied the length by 3, so that will give us the effect of a 3 times extension. So delta L becomes 3 times as much for A. For B, we have got double the cross-sectional area. Okay, so that will halve it. The length is the same, so that's a half. And then C, we have 3 times the length and 4 times the Young modulus. So that's then 3/4. And then the final line, we've got double the cross-sectional area, same length, 4 times Young modulus. So doubling the cross-sectional area and 4 times that means it is 1/8 of the extension if you had X, L, and E. So D is the correct answer.